back with lesson 11.6. We're doing the second half of it that all has to do with setting up your own proportions. Some of them have to do with percents, some of them have to do with parts of an object versus the whole object, and others have to do with one form of measurement compared to another form of measurement, like inches to feet or miles to strides or anything like that. So let's look at how those things are set up. First off, you want to create a proportion. So a proportion is a fraction equals a fraction, and having that set up ahead of time helps you have a place to put everything. So I always draw up that fraction equals fraction first. Okay. If you have a problem that talks about a percent of something and you want to know how many people there are total, or how many objects there are that are part of that whole piece, that's going to be a problem that is like an is over of equals percent over 100. Okay, so the is talking about like the smaller portion of the total amount. The total amount goes on the bottom. Then over here on the right, the second fraction, the percent goes in just as the whole number that they give you, and then the divide by 100, that just means that like 50% would go on top and 100 would go on the bottom. So you just leave it as 50 over 100. That percent over 100 kind of takes care of something we've talked about in a previous chapter, which was changing a percent into a decimal. This kind of does the same thing, but you don't have to do it yourself. Right? So that's one type of problem, the ones where you're looking at percents. Some other problems have to do with parts and wholes. Okay, that is useful in architecture and engineering when you're trying to make plans. Okay, you want to get something that is small and make it big eventually. Or if you're visualizing an entire house, you want to get that smaller so that you can fit the plan onto a normal piece of paper. Okay, the way that that is set up is the part of the object over that whole object is equal to the part of one object over the whole other object. So this guy is going to come in handy when you're talking about similar objects like triangles as well. So there is a problem on your assignment where you have a small triangle and then you have a bigger triangle. So you would do one part over the whole equals a part over the whole. Okay, one other setup that you might come across is labeling. Okay, so this is like when you're trying to turn inches into feet or anything like that. So you're going to have two different fractions which represent two different scenarios. In one scenario, you're going to have a number of inches compared to a number of feet. And then in the second scenario, you're going to have a number of inches compared to a number of feet. Now those can be any labels that you really want them to be. They could be inches over miles, or it could be strides per meter, or anything really, as long as both of the tops have the same label and both of the bottoms have the same label. The first fraction is one scenario, the second fraction is another scenario. Okay, so we'll get back to this setup when we do example 5. All right, let's take a look at example 4. Example 4 says that a college brochure states that 11.5% of the students attending the college are majoring in engineering. If 2,400 students are attending the college, how many are majoring in engineering? Okay, so this is a percent problem, so we want to get that set up so that we have a proportion, so fraction equals fraction. Okay, one of the fractions, it doesn't matter which one, gets the percent over 100. So we know that we have 11.5% of the students, so that's going to be on top, 11.5. Don't put the percent sign, that'll mess up in your calculator. 11.5 over, and then 100 goes on the bottom. Okay. Now the smaller number is on top and the bigger number is on the bottom, and that's going to be the same thing over here. Okay, you have 2,400 students attending the college. How many are majoring in engineering? Well, if there's 2,400 students total in the college, that has to be the bigger number out of the two, so that's going to go on the bottom, 2,400. Then your smaller number, how many students are majoring in engineering, is going to go on top. We don't know how many that is. Okay. So from here, we're going to do that same cross multiplying thing that we did on the top of this sheet. So we're going to take the x, which is from the top left corner, and multiply that times 100. So that makes 100x. And on the left bottom, that 2,400, we're going to multiply that times 11.5 and put that over here, 27600. And then we're going to put an equal sign in between. Okay, now all we have is a one-step equation. We have to get x by itself. X is multiplied by 100. Opposite of multiply is divide. So let's divide both sides by 100. And we end up with, on the right-hand side, just x. On the left-hand side, 27,600 divided by 100 is 276. So there are 276 students that are majoring in engineering. All right, example 5. A pedometer measures how far a jogger has run. So a pedometer is like a Fitbit. It figures out how far you're running by how many steps you've taken. Okay, so to set the pedometer, you must know the stride length. So a stride length is how far it is between your feet as you take a step. Okay. Mrs. Gonzalez counts 328 strides as she runs once around a 400-meter track. So that looks like one scenario right there. We have 328 strides on a 400-meter track. A meter is about 39.37 inches. We want to know how long is Mrs. Gonzalez's stride in inches, because we have to tell that pedometer how many inches the stride is. Okay, so it looks like we have 3 different labels here. We have strides, we have meters, and we have inches. Okay, so we have to probably do this twice, actually. Set up a proportion and solve it, and then set up a proportion and solve it again. No big deal, we can totally do that. Okay, this is going to be the third setup where we have one label over another label equals the first label over the second label again. So let's first take meters and change it into inches, because we know that the track is measured in meters, but the inches, that's how we want the strides to actually be measured. So let's go ahead and do that. There's several ways to do this problem. I'm just picking one of the methods. Okay, so we're going to change meters into inches, meters into inches. Another thing to notice, it doesn't matter which one's on top or bottom, meters or inches, as long as both fractions have the same setup. Okay, we are told that 1 meter is about 39.37 inches. That is one scenario. So 1 meter is the same thing as 39.37 inches. Okay, second scenario. We know that the whole track is 400 meters, 400 up here. So how many inches would it be around the entire track? We don't know. Since we don't know, that's going to be our variable x. All right, let's solve this guy. We're going to cross multiply, so top left down to bottom right. 1 times x is 1x, which is the same thing as just x. And top right times bottom left, 400 times 39.37 is 1,5748. So 15,748. Okay, this is already solved for x. Okay, notice that x was labeled in inches from here. So we know that this is inches for the whole track. Okay, so if you took rulers and measured around the entire track around a football field, that is how many inches you would get. Good thing we were able to do proportions because that would take a really long time. All right. We still don't know everything that we're supposed to know. We want to know how long is Mrs. Gonzalez's stride in inches. So we're going to create another proportion. So fraction equals fraction. Okay. Looks like we are going to use strides and inches as our two labels. I'm going to put ST for strides and inches for the other label, which is inches. Okay. From before, we know that there are 15,748 inches in the whole track. 15748 inches in the whole track. How many strides are there in the whole track? We were told earlier there's 328 strides in the whole track. Okay, so that sets up one scenario. Second scenario. We have one stride. We want to know how many inches there are in one stride. That's the main question. So one stride is how many inches. So the how many is the x setup. Okay, now it's all ready for us to cross multiply. Top left times bottom right. 328x. Top right times bottom left. 1 times anything is itself. So 15,748. Finally said it right that time. And toss that equal sign there in the middle. Okay, you've got a one-step equation now. So let's divide both sides by 328 to get x isolated. So our right-hand side is just x, and our left-hand side is 48.01. X from our problem was labeled in inches, so this is inches as well. Okay, so Mrs. Gonzalez's stride is about 48 inches, which is 4 feet. That's pretty impressive. Good job, Miss Gonzalez. So one stride is 48.01 inches, and that's what she should set her pedometer up to.